Hello everyone. So welcome to PyNet Labs. So my name is Jatin guys, and I will be your instructor for this webinar, which is your diving into layer 2 security protocols. So as this week's webinar is all about the layer 2 security protocols, and the topics in this in this webinar we are going to cover are very interesting topic for your layer 2 knowledge. Like the first topic we are going to discuss is some your CAM table. So with the CAM table, we are going to do some ARP inspection, like address resolution packet inspection we will be doing. In this ARP inspection, we are going to see how exactly the layer 2 devices communicate with each other, and like with the help of MAC address, how they are going to be identified, and like all the headers also we are going to verify in the devices. Then after discussing this ARP concept, we are going to move ahead to the next part, which is your layer 2 security, or we can say your port security, which is essentially, I hope if you have a knowledge of CCNA, so you will be having some good knowledge on the port security concept, but I will give you some extra things on port security as well. And then after we are going to cover up our Dhcp, spoofing and snooping. So all these topics we are going to cover up in your today's webinar, as well as like when we are going to discuss the CAM table, I will give you some introduction to the CAM limitations, like which we discuss in the CCNP and core level.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
Like how the what are exactly the limitations of your CAM table and how it is different from each other. So we will see. Now let's get started. So as you all know that guys, normally if we are talking about a switch, so let me write the heading, layer 2 security protocols. So if we are talking about the layer 2 security protocols, the first thing before starting the protocols, we need to understand is a switch. So if we are talking about the switch, so we all know that switch is a layer 2 device, which is a layer 2 device, which works on the layer 2 of OSI model, which is your data link layer. So over the data link, we know that like data link layer is responsible for maintaining the MAC entries. So we can write MAC here also, as well as it is going to work on the concept of frames. So frames are also there, and we will also verify these frames in the packet tracer, like which frame is going to, generate the which kind of IP and which kind of MAC address is there. So all these things we are going to discuss. So now let's get started. We will see like normally a switch will automatically learns the MAC address and fills the MAC address table, which is like known as a CAM table. So like if we are talking about the working of a, we can say switch. So for example, let's take a scenario that we have the switch here. This is your switch and we are connected to some devices here. This is your PC1 here. This is your PC2 here. This is your PC3 here. So these are the three PCs. Let's say here one PC is having AA MAC address, 2 is having BB MAC address, and 3 is having CC MAC address. So if you are talking about the CAM table of the switch, so switch is going to create one CAM table here. So in this CAM table, first of all, it is going to store the information of VLAN, like which VLAN these ports are the part of. So let's say we'll assign the port numbers here also. So let me write it with the red pen. So this is port number 1, this is port number 2, and this is port number 03. Now when we check the CAM table, so there is VLAN and then we have the type of port number, like which port number we are connected to. Then after we have some type of MAC entry, so either it is static or dynamic. So this kind of scenario your CAM table is going to create. By default, we all know all the switches are in, like all the interfaces of the switch are in the VLAN one. So let's say, and like here we have the MAC also. So let's say we have this port number FA01, which is having the MAC address of AA. All right, the MAC address we are going to write here in the MAC entry. So the MAC address is AA. So it is having the type of MAC address is dynamic. Then again, the next interface we have connected is, let's say this 02 I'm talking about. So this is also dynamic and this is having the MAC of BB. Again, we have some port in VLAN 1, which is FA03, and like the state again is dynamic type of MAC, and the MAC is CC. So now guys see this process, like, if we are talking about this process, like whenever, like, by looking at the source MAC address of the incoming frames, and then the switch is going to flood the frames that it doesn't know where to forward the frame exactly. So for the very first time, we all know that switch is going to broadcast in the network. Then after storing the MAC address, switch is going to switch is going to unicast the traffic. But what is going to happen? This process is like we can say pretty much vulnerable to the layer MAC address spoofing attacks, where any attacker is trying to spoof a certain MAC address or to change the entries of MAC table. So a simple method is to deal with these issues manually, is to configure the MAC table entries statically. Like I will show you on the packet tracer. Let me share my packet tracer screen. So here is my packet tracer. As you can see, like I have taken one topology here. This will be our topology, which we are going to check out. So this is our switch 0, and these are our 4 client machines, like PC number 1.1.1. So this is the IP of the PC which I have executed. Here you can see this 111 is the IP, and we can also verify the MAC address of this particular PC. So to verify the MAC entry, we will write ipconfig/all. And this is the physical address, as you can see here. Like if you will see, I'm going to copy the physical MAC address here, and I am going to paste the MAC address here below this PC, which is your 1.1.1. So this is the MAC address of this PC, and one more MAC address. Let's say I'm going to verify the MAC entry of this PC, so which is 1.1.4. So same command you are going to run in the command prompt, and you will write ipconfig/all. So here you got this MAC address. So this is the MAC here we got. Now copy paste the MAC address here. So we have copy pasted the MAC address. Now if you will see, like I am trying to establish the connectivity between all the devices. So if you will see that I am going to establish the connectivity with the switch, like as of now, I will also verify with all these switches. So if you will see in the switch, I am going to establish the connectivity with all these switches. So if you are going to check out, like we will go on the switch and I will show you enable show running config. So you can see as of now, there is no configuration on the device here. So all these interfaces are empty, as well as we have not done anything, like there is no VLAN configure, like nothing is there on the switches. We can also verify show MAC address table. So here you can see the MAC address table is also empty. Like I told you, VLAN is there, MAC address is there, type of MAC is there, and what is the port number, which is statically or like which is binded to that particular port number. So if you are going to see here that we will see the ARP inspection. First of all, we will see how the address resolution protocol is going to work in this case. So for that, like, as of now, there is no MAC entry on the switch. So we will just inspect the ARP packet. So I'm just minimizing the switch and I'm going to open my simulation here. So this is our simulation, and like, see here, these routers and switches, like I have taken these switches for backup purpose. So like now we will see here, this is our simulation mode. Now, if you are going to verify some packets, let's say I am going to drop one packet from this PC1 to this PC1.4. So let me explain you theoretically first, like what is going to happen in the real environment first. Like let me just put that snip here on the PowerPoint. So this was our image, like which I was discussing with you all guys. So you guys see like what is going to happen in this scenario, that whenever this PC 1.1 is trying to communicate, let's say this PC 1.1.1.1 is trying to communicate with 1.1.1.4 PC. So it is going to generate the frame, and the frame will go from this PC to this interface, like on the FA01 interface, the switch is going to receive that particular frame, right? So once this switch is going to receive that particular frame from this PC1, so there is an entry created, like when a frame is generated. So we all know that some source IP, some destination IP, and some source MAC and destination MAC kind of entries created. So in that case, this switch PC will also generate the header, like the source IP, destination IP, source MAC and destination MAC, and then generate the frame. The frame will be received by the FA01 here on the switch. Then switch will do what? Switch will store the MAC address of this PC, like this MAC address will be stored and reserved with this specific interface, which is FA01 in the CAM table of your switch. Then as we know that, like, see guys, let me show you one more thing. There is, like, we all say that switch is going to broadcast for the very first time in the network. So why the switch is going to broadcast in the network for the very first time? So just let me close my simulation first and we'll go on the switch again. And there is a concept of broadcast domains in the switch, like, so we can verify show VLAN brief with the help of this command. So I hope you all know the concept of VLAN. If you don't know, like, you can go through with our videos. So you'll find the concept. So see, like VLAN, whenever we are talking, it's something like a virtual local area network. But when you will see, like, there are total 4094 VLANs on the devices. But here you can see like all the ports of this specific switch, like all these FA024 from 1 to 24, all the ports and some 2 gig and gig ports are also there, which all are stored in this VLAN, like VLAN 1. So this is one of the reason, like we can say that whenever any PC is going to send the frame to the switch don't know the destination MAC address, because switch do not work on the like, you know, IP address. So switch needs to identify the MAC entries of the connected devices. So how exactly we are going to see that? So if you will simply see that when this PC 1.1.1 wants to communicate with this 1.1.4, so this PC is going to create one entry. So first in the entry, it is going to create the source IP. So source IP is what? 1.1.1.1, the IP of this specific PC. Then the destination IP will be there. So destination IP will be what? 1.1.1.4 is the destination IP. And in the another header, it is going to generate the source MAC. So source MAC will be 0003 dot EA4D, sorry, it's E4AD and like dot 72D7. So this is the MAC address which I have just copy pasted from here. Like this is the source MAC of this PC 1.1.1 and the destination MAC, like we don't know the destination MAC. Now this PC don't know the destination MAC, like where I want to send this particular frame. And as we know that normally switches are going to work on the MAC address, like as they are the layer 2 devices, right? So like switches are going to use the MAC address, like we can say CAM table, to do the destination based forwarding. And you can see that like CAM table cannot be summarized like the IP routing table of the switches, like the routers, we can say. So if you will see like how we are going to differentiate that. So we are going to put the simulation on now and we'll go and verify the MAC entry of the switch here. So I'm going to show MAC address table. All right, it is not gonna work here. Yes, so we will now verify the MAC address table. So you can see as of now, there is no MAC address table like in the switch, like switch has not received any frames as of now. So if we are going to see the simulation and we will see that I am going to drop one packet from PC 1.1 to 1.4. So there are two packets which are generated. And if you will inspect these packets, so let's try to inspect this ICMP packet. So if I'm going to double click on the ICMP packet, you can see the layer 3 information we are getting here. Like in the IP header, we get the source IP, which is 1.1.1, which I have already mentioned here. Destination IP is there, 1.1.1.4 is also there, like, and then the ICMP message type is also there. Like there are various types of ICMP messages which we can read in the like blogs of our website. But as of now, that's not the part to discuss. So this is like the layer 3 header which we are going to inspect. Then try to inspect the ARP packet. This is your layer 2 packet. See, in the layer 2, we have the source MAC, which is 0003 E4AD72D7, as I have already copy pasted the MAC. And ARP packet source IP also it is using destination IP. But after this some FFF you are getting here. So this F is representing to the global broadcast MAC address here, right? So whenever we are talking about the global broadcast MAC address, it is used to broadcast the frame on all the connected clients so that the switch is able to get the MAC entries. So now like how the address resolution protocol works. So if we are saying that what is address resolution protocol, so ARP is something a concept why with the help of the ARP, the switches are going to generate like the MAC entries using the help of source and destination IP. So here also, if you will see that on the PC 1.1.1 and 1.1.4, we know the MAC address, like we know the source MAC, but we don't know the destination MAC. So the switch is going to figure out, like with the help of source and destination IP, say if we'll try to capture the packets now, the frame is sent out on the switch one, and switch one will broadcast the frame, like for the first time it broadcast, and before broadcasting, see, it has also stored the MAC entry of FA01. Like other PCs have rejected because they know that we don't have this 1.1.4 destination IP, but 1.4 replied back to the switch and the packet was generated. So if you will now check, like we have tried to communicate between two devices. So like I showed you simultaneously when we were doing the ARP inspection that once the frame was received on the FA01 interface, so that particular interface was like, we can say like has stored the MAC entry, and you can see here the type is dynamic MAC entry. I will explain you this, like what is this dynamic here. Now, if you will again verify the MAC address table, so you can see like the communication was from FA01 to FA04. So both of the MAC addresses are stored here. So this is what like some ARP inspection we can say. And apart from that, like if anybody or like for interview perspective or if for personal knowledge you are going to understand what exactly ARP is. So we can say ARP is a protocol which is used to find the MAC addresses of the connected clients with the help of source and destination IP. Because without source and destination IP, we won't be able to we are not able to figure out the MAC entries if we don't know that the source and destination IP. So that is acting as a medium for us. So this is what all about your ARP inspection is, guys. Now there are some, layer two switching design problems. We can say like, Ethernet networks used to have scalability limitations based on the collision domain sizes. Like in that previous traditional networking, we can say like hubs were used. So we use some hub duplex and CSMA-CD concepts and all those parts. But if you will see like a layer two switches segments the collision domain on per port basis to solve this problem, right? So we can say that layer two switches have a scalability issue based on their total host in the network as per the host in the broadcast domain, we can say. So there are some limitations related to that if we are specifically talking about the CAM table. So just let me write the CAM table limitations here. So just let me raise this part here, and then we will discuss the CAM table limitations, like what are the CAM table limitations and how the CAM table is going to be understood, we can say, as per this webinar. So like you all know that switches are going to use the like MAC address. So MAC entries are prior part, which we have already discussed how the switches are going to use the MAC entries. After the MAC entries, what we can add is like, CAM table. CAM table cannot be summarized like IP routing, which means like whenever we are saying this point, like when it cannot be summarized like the IP routing. So that means like, the CAM table, we are not able to manipulate the CAM table. Like if you will see here, we saw this dynamic. So there is some static MAC entries also, but apart from that, there are no other options. So if anybody is going to ask you like how many MAC addresses a switch can store, so as such, there is no specific count. That depends on the vendor also. But if you want to verify, like if you want to check the size of the CAM table, so there is a command which is show MAC address table count. So this is the keyword count you need to add afterwards. Like in packet tracer, I'm not able to show you, but yes, for sure, I will show you in the Eve machine, like when we will verify that how many MAC addresses are there. So with the help of this command, show MAC address table count, like if you will run in the real environment and the real production environments, or if you are going to run this command in the EvenG or your GNS simulators, so you will see that like it will show you the exact count of total MAC addresses your switch can store. So guys, see, now coming to the point, like what exactly we are about to discuss. So as we know that switch is the networking device which we have discussed, like it is going to store the MAC address of the connected clients to verify which command, like we have already used show MAC table. So like, I do have one question, guys, like how many MAC addresses we can store on one single port of the switch? Like if I am showing you the packet tracer screen. And I'm talking about the MAC table. See, like, let me generate some package from all the devices. So let's try to generate some package from PC 1.1 to 1.2. From 1.2 to 1.3, you can see communication is successful here. And I'm going to drop some package from 1.3 to 1.1. And now we are going to verify the MAC table. So we'll run the command show MAC address table again. And if we are going to write enter, so you can see like all the MAC entries are stored inside the switch here. Now, if you will see that all these MAC entries are showing you that these are some types of dynamic entries. So there are two types of MAC entries which are created in the switch, guys. The first is your dynamic and the next one is your static. So dynamic means like it is automatic, like after 300 seconds. Like for example, if these PCs are not communicating like with each other for 300 seconds, like they are idle in the network for 300 seconds, then this entire information is flushed out. Like, see, let me show you. We are going to fast forward the time and we will see. So now I have fast forwarded the time. And if you are going to verify again, show MAC address table. So you can see all the MAC entries are flushed out. So if in case the PCs are idle for 300 seconds, then that means like there will be like the flushed MAC entries will be there. So in that case, we can statically put the MAC entries also. Like now I will show you how. But I just raised one question to all of you that how many specific MAC addresses, like for example, this is PC 1.1 is connected to FA01, dot 2 is connected to FA02, dot 3 is connected to FA03, dot 4 is connected to like 1.4. So if you will see here that all these IPs like source IP, destination IP, source MAC, destination MAC. So like, in the CAM table, all these entries are there. But what I just wanted to say is that on specific interface, as for example, this PC 1.1, it is connected to this FA01 interface here. If I will say that how many more MAC addresses, as of now, we have checked that only one MAC was there. But if I say that how many total MAC addresses we can store on this particular interface. So guys, there is no limitation on a single port that how many MAC addresses you can store on one single port of the switch. So this is something like we are going to discuss now because see, I'll show you how exactly this varies. So I will verify configure terminal. I am going to select interface, but before that I will verify some port security to you. Show port security. There is no port security. Show port security. Interface on FA01. Now I am going to see the port security on the FA01 interface. So you can see like port security is disabled by default. And total MAC addresses on this interface is 0. Like maximum MAC addresses allowed are 1 here. So right now by default you will always see that 1 is there, but you can also change these values accordingly, like according to the need of your like ease of use. So as such, there is no limitation for single port and you can add as many as multiple MAC addresses. Like you can also verify in packet tracer, we will see like, see how many MAC addresses we can add. Interface FA01, I'm going to select, then I'm going to write switch port mode access and then switch port security maximum. And I will put question mark. So maximum MAC address the packet tracer allowing is 132. But if you will verify in the GNS or in the EVNG machine, so you will see that it is something around 4097. And depending upon the real environments, you can also verify like how many maximum MAC addresses you can store on that particular interface, right? Now coming to the part, guys, like what we were discussing. So we were talking about there is an attack which is known as like MAC table or CAM table overflow. So just let me use my PowerPoint here. So whenever we are talking about the attack, so there is an attack which is known as your MAC or CAM table overflow. So if you will see here, like what normally happens, guys. Let's say if there is any attacker and he got access to your switch. So for example, let's take that snap again here. So this is our scenario which we are taking just to understand. Let's say this is our production environment and some attacker here got access to the network using our switch. So here the attacker got the access here. Now if you will see that let's assume that this is an attacker. So there are various multiple operating systems like Kali Linux is there, like we can say Parrot OS is there, which are used in securities. So which can be like, that kind of this kind of operating systems are responsible, or like they have some features or capabilities that they can generate lakhs of MAC addresses just in a 1 minute. Like in just 1 minute, they can cross the limitation of 1 lakh MAC addresses. So when a attacker, like let's say this attacker got access to your network anyhow, and he is using some Kali Linux, and he's trying to send some fake MAC entries here in the switch. And now if you will assume that, let's say the MAC table size is like, let's say total 1000 MAC addresses is the count of MAC table, and the attacker completed this 1000 MAC table count. In that case, like if the MAC table is full, then now if the PC1 wants to communicate, so what is going to happen in that case when the MAC table is full inside the switches? So when the PC1 will send the frame to the switch, the frame will be dropped, because as we know that switch will receive the frame and it will try to learn, but before like it will try to learn the MAC address, it will simply drop it because the MAC address table is already full by the hacker. So this is the attack, which is known as MAC CAM table overflow. We can call it as MAC or CAM. MAC stands for media access control. CAM stands for content addressable memory. Then this switch will not accept the frame. Back to the point. So it will just start flooding the frames inside the network. So what usually happens when like your CAM table is something like, when your CAM or MAC table is completely filled, your switch started acting like a hub. So as we all know, that hub is going to broadcast in the network every time. So like it will broadcast the network again and again in the network. So this is what basically the attack is, guys, like the MAC table overflow. So we can say that this is a type of attack. And what is the prevention to this attack? So the prevention to this attack is your port security. So by port security, like, port security allows you to limit the number of MAC addresses on the interfaces. So basically by port security, you can assign number of MAC addresses and you can specifically fix the port that it wants to learn the MAC, or like it wants to drop the packet. Like you can specifically reserve like this PC, this MAC address is specifically reserved for FA01 port. Now any other PC will come and try to connect with this FA01 port. It is not going to accept any frame that from that particular uh, connected client. So I will show you like whenever we are talking about the port security, guys. So like there are some violation methods in the port security. We have first is your shutdown violation, which is always the by default. The second we have is the protect violation. And the third we have is the restrict violation. So these are the three types of parameters which port security follows. And I will also verify each and every point which I am writing here on my PowerPoint slide. Like what exactly the shutdown, what is protected, what is restrict. So we will just have a lab scenario. Let's try to understand all these port security concept here. So if you will see like the port security part, just opening my packet tracer. This was our scenario. Now you can see, like, see, this FA01 interface is there. Now what I will do is I'm going to configure some port security on FA01. So previously, like before that, let me verify you. Show MAC address table. So you can see as of now, there is no MAC entry here on the switch. So if you will see that enable configure terminal, as also I will verify, see, show port security. So there is no port security, show port security on interface FA01. So you can see like the port security here is disabled and the port status is secured down. Violation method is shut down. Maximum MAC address is 1 here. Total MAC addresses are 0. Sticky is also there. I'll explain you what is this sticky. So let's try to configure on FA01. So we'll go and configure terminal. We are going to select the interface FA01. And then first of all, like the port, if you will run the command, switch port security. So with the help of this command, we are going to enable the port security because FA01 is already like in the like we have already enabled the switch port mode access. So like you also need to run the command, but we have previously run that command. So I don't need to write that again here. So let me show you where. See, I selected the interface FA01 previously, then I written the command switch port mode access. So you need to put the port into access mode. then only you will be able to configure port security on the switch. So once port security you have enabled, then you need to write switch port security maximum how many MAC addresses you want to apply on this particular interface. So see, 1 to 132 are there. I'm executing maximum one MAC address will be reserved for this specific FA0 and 1 interface. Then switch port security, you need to define the MAC address also. So there are two ways I told you, statically and dynamically. Dynamically means automatically it is going to take the MAC entry. But when it comes to statically, you need to write the MAC address statically. So I'm just going to copy paste the MAC address here. So this is the MAC address which I have pasted. And if you will write switch port security, like there are three parameters, violation, and I'm going to show you, see, protect, restrict, and shut down. There are three violations here. So now you will see that by default, all the switches are in the shutdown violation. So if you will not configure this violation command here, that means like port security is there, like it will only accept the shutdown policy. So show port security interface FA01. Now you will see port security we have enabled. Port status is secure up. Violation mode is shut down. And like the total MAC address and the configured and the maximum MAC address here you can see is 111. So now let's try to check the MAC address table also on the switch. Show MAC address table. So you can see this FA01 entry statically we have binded up with this particular MAC address and this resolved with the FA01 interface. Now, if you will see, we are trying to communicate all these PCs. So I'm going to ping. So here we can try to ping the traffic, ping 1.1.1.2. So here you can see like we are getting the replies from 1.1.2 machine. We can also try to ping it with 1.1.3. So we are getting the replies. You can also try to check it with 1.1.4. So if you will see that we are getting the replies from that all the PCs are able to communicate. Now, if you will verify the MAC entries, like previously only one MAC entry was there, but you will see like all the MAC entries are there. But here we have one static entry, which is your static MAC entry, which is connected to via FA01, where we have configured the port security, which is shutdown violation. But if you will now figure out that you, all right, so I'm just going to show you one more thing. See, now I'm going to take one laptop here, like from the devices. Let's say this is an attacker here. So now you know that this laptop will be having its own MAC address. So let's verify what is the MAC address of this laptop. So ipconfig/all. So you can see this is the MAC address 0060 copy. I'm going to copy this MAC address and I am going to paste the MAC address with this laptop only. All right, need to copy that again. This is the MAC address 0060 and I'm going to copy paste the MAC address here. So if you will see here, like with this laptop, I'm going to connect this laptop again with this switch, like this as an attacker. So we'll assign some IP on this laptop also. So let's assign 1.1.1.10. This is the IP for this laptop specifically. And like I have fast forwarded, and we will also try to generate the communication. See, from this PC to this PC communication successful. Now, if you will check the MAC entries, the laptop is connected to the FA05 interface. So you can see like one static entry is there, FA05 and FA02 and FA01 is also there. But see guys, what is going to happen that if this hacker tries to connect to this PC number, your like in place of this 1.1 PC. Let's say this PC is residing over the reception of our office. And if you will see over this, like this laptop is there, like this attacker got on the reception and he saw that this PC is idle. So he just simply tried to plug out that cable and plug in the cable inside the laptop with this interface. So what is going to happen? See now, once the laptop will generate the frame, now you will see something here. So the laptop is trying to generate one frame, like the switch port is going through with some listening and learning stage as of now. So if you will see like once it is going to generate one frame, the port will automatically be put into the error disable state. So let's fast forward the time. See, like connectivity established. Now I am going to ping with any other computer. Like previously the laptop was able to ping. So I am again going to ping with 1.1.1.2. So you can see the port automatically went to the red state, and also we got some error here that interface FA01 changed the state to administratively down here. Like, which means if the shutdown violation is there, your interface is gonna be in that error disabled state, which means it is not going to accept any frame from any other connected client which is having different MAC address. So like no PC is allowed to communicate over this specific FA01 interface. Only this PC is allowed to communicate over there. So we are gonna see. Like I'm going to remove the link from laptop and connect back it to FA01 dot this PC 1.1.1. Now you need to go on the switch again and you need to select the interface FA01. Shut down, you need to manually forcefully shut down the port and then you need to no shut down the port. Then it is going to work functionally fine. Now this PC 1.1 is able to communicate with the entire network. So you can verify, you can see you are getting the replies here. So this is one of the method of port security using some shutdown violation, which we have discussed. Now coming back to the next violation method, I will show you something different. So here we are going to discuss the port security on the, let's say, restrict method, like not on restrict, we'll discuss the protect here. So I'm going to configure port security on this FA04 interface. So if you will see, I'm going to run the command interface FA04 switch port security. So see, this is what I wanted to show you in the last slide, but see, okay, we can verify command rejected. FA04 is the dynamic port. So we need to run the command switch port mode access first of all to configure the port security, then switch port security, switch port security, MAC address, sorry, maximum. Now how many maximum MAC addresses we want to execute? I want to execute 2 MAC addresses here. Now I have executed 2 MAC addresses here. Switch port security. Either I can statically write the 2 MAC addresses or I can write MAC address sticky. So sticky is a keyword which is used here. I will explain you what is this sticky, but let me write the command switch port security violation. And I'm going to use protect here. Now here, see guys, I am not using the static kind of entry of MAC address. This sticky command means like, for example, whichever the two PCs are going to communicate with this particular FA04 interface and like the first two MAC entries, like the first two frames received on this FA0 frame, FA0 interface will be stored in the MAC entries. Like let's try to copy the MAC, like ping some traffic. So from this, we are going to ping 1.1.1.1. So we are getting the replies. Also, like again, on this FA0 interface, like let's say FA04 interface, I'm going to connect the next PC, which is your 1.1.3, which is our organizational PC. Now we'll fast forward and try to ping with 1.1.2. So see, it will also communicate ping 1.1.1.1. So it is getting the reply again. Now, if you will verify the MAC table here, you will see that on the FA0, there are two static MAC entries. Show MAC address table. So you can see FA04 is having two MAC entries here. The first entry is for FA04 and the another one is for the FA04. So we can verify one MAC address is 000A F3754A74. This is the MAC of this PC number 1.1.4. and 000216A0. This will be the MAC of this 1.1.3 we can verify. Sorry, it's ipconfig/all. So you can see this is the MAC 0000216A0. So this is like two MAC entries are stored. But if you will see now again, the hacker tried to get access with this FA04 interface. So he got the access. Now he wants to communicate with these devices using the FA04 where we have executed the port security. So if you will see that port security we have executed here, that means like over this switch, like the port will not go in the shutdown state. See, let me show you when we run the command show port security. So you can see on FA01 and FA02, like on FA01 and on FA04, we have executed the port security. And on FA01, we have executed 11 MAC address, whereas on FA04, we have executed 22 MAC address and the violation is your protect. So if you are gonna see that 2 and 2, like these are on the protect. So another PC, if this is trying to communicate, so if we will try to generate some traffic here, so we can see ping 1.1. So we aren't able to communicate, but the port is still not in the down state. See, on the switch also you can check like there is no log generated, which means like in the protect, the port is allowed to stay up, like whereas in the shutdown, like if any other device gonna connect to the PC, that means like the port is gonna be in the shutdown state, but whereas in the protect, it is not allowed to go in the shutdown state, and like it is allowed to stay in up state, or we can say like, the switch interface stops learning the MAC address. So this is what your protect is. Now coming to the restrict policy, what exactly restrict is? So on FA02, I am going to configure restrict, and we will see the restrict configurations also. So the commands are same. You need to select interface FA02, switch port, mode access, switch port, port security, switch port security, maximum 1. All right, maximum 1 only. Switch port security, MAC address sticky, and switch port security, restrict violation I'm gonna use. Now see guys, what is the meaning of this restrict here? Like what parameter this restrict follows. So if the attacker got anyhow access to the device, let's establish the link with this PC also. So if this attacker anyhow got the access to this FA02 interface here, where we have configured the restrict policy. So he's able to communicate inside the network, but you will see like when we will run and verify the port security command again here. Show port security. So you can see FA01, 2, and 4 are configured with the 3 violations: shutdown, restrict, and protect. So restrict is configured with FA02, where only MAC address count is 1. Now, if you will see, guys, I am going to connect this PC and like generate some traffic first from PC 1.1.2 so that the MAC address can stick to the FA0 interface. Okay, it failed. Actually, I guess the MAC address of laptop has sticked with the. So ping 1.1.1.1. All right, we are getting the replies. Now we will see the MAC table here. So MAC address table. So you can see with FA02, we have statically binded the MAC address. Now, if you are going to see that this laptop is going to try and get the access here. Let's fast forward and let's try to generate the traffic with 1.1.2. All right, 1.1.2 is not in the network, so 1.1.1. So we aren't able to get the communication here. But if you will see like the port is still up, but if you will do check out something in the verification part of the switch, show MAC address table. So you can see show port security, sorry. Show port security. So you can see like there is a security violation count in the restrict, but see this the security violation count means like any time the hacker is trying to get access inside your network and what kind of traffic the user is trying to generate. So that part is like, comes in this restrict. So we get some security violation count. So for how many times the user is trying to get access to the network. So this is all about the port security. Just let me brief it up. Like we have discussed the 3 violation parameters: shutdown, protect, and restrict. Shutdown means like the port will go to the error disable state if any other MAC address device will be connected. Protect means like the port will stay up, but port will stop learning the MAC address, and also no violation count is there. And we can say like if we are talking about the restrict one. So in the restrict, we can say that restrict is gonna have the violation counts as well as the port is also allowed to stay up. So like what is the best measure to use the port security? Like it is always recommended to use with the restrict violation so that we can also have the log counts that what is the user trying to generate in the network. So this is what basically your concept of port security is, and like how this is how we are going to cover up, like we are gonna wrap up this port security part. And this is all about your layer 2 kind of security. Now coming back to the next scenario, guys, like as of now, we have enabled port security on this switch. So this switch is of no use to us. So I'm going to delete this switch and I'm going to take one switch, which is our backup switch. So I'm going to delete this switch and we will take this switch 1 here. And again, we are going to connect all these 4 PCs back to the switch because we are going to see some different concept here. And also we don't need this MAC address. So we'll connect this switch with these PCs. So also I'm going to remove the IP addresses here. Like this is your PC A, let's assume. This is your PC B. This is your PC C and this is your PC B. And I'm going to take one router here, which is your organization's router. And this, let's say one router I'm separately going to take, let's say again, this is your another router. So let's name this router as attacker. So this is an attacker router. So for example, if you are going to work in a production environment where you are going to use the Dhcp. So configuring Dhcp is, I hope you all know, because this is now I'm going to show you something else. So here I'm going to execute some gateway on gig 00. So let's say 192.168.1.1 I will be executing on gig 00. And I'm going to configure some DHCP on this router. So enable configure terminal interface gig 00 IP DHCP. All right, IP address, sorry, not DHCP. 192.168.1.1 255.255.255.0. So this is the IP I have executed and no shutdown. Exit. Now we'll configure the DHCP here. So IP DHCP pool and the pool name I'm going to give as, let's say, PyNet. So my pool name is PyNet here. Now I need to execute the command for the DHCP. Like I say, I need to define the network 192.168.1.0. So the subnet mask 255.255.0. Then the default router will be, let's say 192.168.1.1. This will be the default router. DNS also we can execute, let's say 9.9.9. We can execute any DNS, that's optional. Or like configure terminal IP DHCP excluded address 192.168.1.1. That I don't want this address on any of the devices. So this is what basically your DHCP configurations, which I hope you all know. Now see guys, what I'm going to do is on this router also I'm going to create some DHCP server. Over this gig 00, I'm going to execute some IP, let's say some 172.16.1.10 or 100. This will be the IP we are going to use on this gig 00 interface. And on this attacker router, we will also configure the DHCP. If you didn't get the DHCP configurations, you can verify again here. Configure terminal. Host name I'm changing to attack. So this is our attack router, and we are going to select the interface gig 00. IP address, we are going to execute 172.16.1.100. 255.255.0.0 and no shutdown. So this is basic IP configurations we have done here. Exit. I'm going to configure the DHCP, IP DHCP pool, and the pool name I'm going to give is attack name. So after giving the DHCP, I need to define the network. So the network I'm going to use is 172.16.1.0. 255.255.0.0, and then we need to define the default router as well. Like default router represents here the default gateway, which is 172.16.1.100, the IP which we have executed here as the default gateway. And DNS, if you want to use, you can use, let's say DNS server I'm going to use as 0.0.0.0. Now configurations are done. You can verify show IP DHCP pool. So you can see like we have configured the pool here for this network, and also on that network we have the pool. So if I'm going to take the IPs by the DHCP, so we will see that which PCs are going to give the IP. So here we are getting from 172 network like 172.16.0.1, and some gateway we are getting from 192.168.1.1 DNS server. Like the IP we are getting from the this organization router, which is having the logo of PyNet. But on the other side, the gateway we are getting from the like the IP we are getting from the attacker, and the gateway we are getting from the PyNet's router. We'll verify on the next PC. DHCP. Here also the same thing we are getting. We can verify the DHCP again here also. So same thing is happening here. IP DHCP we are getting here. Let's see. So here we are getting the IP from this router one only, like 192.168.1.1. So here in this kind of scenario, you can see like I have configured a normal scenario. Let's talk about this selected part first. Like this is your organization, like where you are working some like with some 100 employees, and you have a router configured with the DHCP. So as you all know that DHCP works on the DORA process. So what happens, like, if there is any user who put some router with DHCP in the middle and he is just trying to get the access. So this is somewhat like the man in middle attack kind of concept is, which means this attacker is able to capture the traffic from your network. Now, how the this hacker is able to capture the traffic? Means that you will see that here we are getting the IP address like DORA process. If we are talking about the DORA, D stands for discover, like DORA I'm writing, discover, offer, request, acknowledge. DORA process is there for the DHCP. So if we are talking about the DORA process, like the client is going to request for the first time, that is the discover request. So as you all know that the discover request is sent to all the that the discover request is broadcasted in the network. So like excluding the client machines, every other router in the network will understand the discover packet, because like then only it is going to offer, then the client will request, and then acknowledgement will be there. So if I'm specifically saying like, let's say discover, offer, R means request, A means acknowledgement. So now you will see this discover requested is always broadcasted via client, like, or we can say not the broadcast. It is discover is always done by the client, or is by the server, because DHCP is a client server model. Request is again done by the client, and acknowledgement is done by the server. So this is what the entire DORA process looks like. And we can see like here, these are the two routers which are able to understand the DORA process, because DHCP is a protocol which we are going to configure on these routers, because switches are not able to understand the DHCP process, right? So as of now, like the attacker can also do some DHCP starvation attack, like which means the attacker, like this 2911 router here, this router is able to, like, let me highlight this one as an attacker. So this attacker router is also able to, we can say complete the MAC bindings of your this router. So once the MAC, like the routing entries are full, like if you will see here, like this is I'm talking about, show IP DHCP bindings. So here we can see we are getting the bindings here, like only 255 bindings can be there for one network. So if this attacker filled the entire bindings with this router, like, so in that case, all the PCs will be getting the IP from this attacker router. So this is not like something, relevant solution. So in that case, like we have some concept of DHCP spoofing and snooping. So basically, guys, like we have some concept of this snooping and spoofing. So spoofing is something which is known as the attack. Like this attacker is what it is doing in between, like some man in middle attack kind of scenario it is creating, or we can say that it is performing the DHCP spoofing attack. Now, what is the prevention? The prevention is snooping here. So like as for the scenario which we have discussed, so before performing the DHCP spoofing, the attacker can also perform more attacks like DHCP starvation, like completing the binding table of this router, so that any client machine is going to, a request for DHCP, then this router is only able to provide the IP address, right? So which means the attacker first will send some fake discoveries to the DHCP server, like the original DHCP server in the network, and then it is going to start sending some fake kind of discovery messages, right? As I have already written here, discover is always done by the client, offer, request, and acknowledge, like it is a client server. So discover and request are done by client, whereas offer and acknowledgement is done by the server. So now guys, see, now we will tell the switch, like on the DHCP snooping concept, we are going to do that on the switch. And it's just a 1 or 2 minute kind of concept. Just focus on this part, that like it's a very easy concept, that on this switch, we are going to say that which particular interface is your trusted interface. Like for example, both of these interfaces, FA05 and FA06, are able to, receive or send the DORA request, like a discover request will be sent via this FA0 or FA06 also, 5 or 6. Now we will tell this switch that we are creating one trusted interface so that the trusted interface is only going to receive what? The offer and acknowledgement packet from that trusted DHCP only, not from any other DHCP in that case. So how we are going to do that? So we are going to select the switch first of all. So we need to run the DHCP snooping command for all the interfaces. So like we can put it, make it more secure. Configure terminal, we will write Ipdhcp snooping. So this is the command we have enabled like in the switch. Now Ipdhcp snooping VLAN 1 because by default all the switch ports are in your VLAN 1 here. Then after one more command we need to apply in the switch. Like now you need to select the interface. Like either you only want to receive the DHCP request from this FA05 or FA06. So trusted is FA05 here. So we will select the FA05 interface FA05 and we are going to make it as trusted interface. So IP DHCP snooping trust. So this is your trusted interface and exit. If you want to verify, exit again, show IP DHCP snooping trust. Right, snooping. Here we can see yes. Show IP DHCP snooping. When you will run the command, you can see FA05 is the trusted interface here. Now option 82 is untrusted on this port is not allowed, which means like if you have gone through with some DHCP relay agent concept, you understand option 82. So we need to run one command like we need to go on the configure terminal, no IP DHCP snooping information option. So why this command is running VR? So basically like to understand the DHCP, there is an option 82. Like if you want to study about the option 82, you can find out on our YouTube channel, like some videos are created for DHCP relay agent there. In that relay agent concept, you will figure out what is the option number 82. And also we will add some links with the blogs of DHCP and all the entire concept we have discussed. So here you can see like we have enabled this command. Now, once you are going to see like previously, like all the PCs were getting some IP from 172 and some gateway was also misconflicted here. Now again, we will run the DHCP request. See, we are getting 192.168.1.7 and the DNS server 999, which we configured on this PyNet router. And the subnet mask is there and the default gateway is actually fine. So if we will again verify on this PC, here also there were some misconflictions. Again, we will take the DHCP. So it has 1.9 and this is 1.1 again. All the entries are now relevant from the specific router from that router where we want all the entries. So you can see 192, 1.10 and 1.1 is there. Also, we have this PC, so we can also run the DHCP command here. So 1.11. So this is what basically the DHCP snooping and spoofing concept is. So it is all about your we can say that DHCP snooping and spoofing. So it's all about the trusted interface, which interface you are going to make it as more trusted. So that is all from my side in this today's webinar, guys, for your DHCP snooping, spoofing, layer 2 securities, including the port channel, ARP inspection, cam table. Any specific queries you guys have from my side, so you can just please let me know your queries or like I'm ready to help you out on the queries. So you can put your queries on the over the chat box if you have any. So I guess there are no more queries, guys. So one more thing, like I just wanted to update you all that in PyNet Labs, as a second anniversary gift of PyNet Labs, we have just launched one CCNA training also. So that is starting from tomorrow. If you have not registered for that training, you can just go through with the PyNet Learning Telegram channel, and over there you will find all the relevant information. And you can just subscribe to that link and then you will be getting some message and you will be able to join the free training for entire CCNA, and you will also get some certificate for that training if you have 80% of attendance in that training and you are actively participating. So this is some like bonus point which I am adding here for you all. So guys, that's all from my side. If still any queries are there, so you can let me know or we are good to wrap up then. Yes, Zishan. You can use your chat box to write. I missed the part PC was taking the hacker DHCP. Why not PyNet router? All right, Zishan. So the query like you are asking, like I missed the part, the hacker DHCP IP. Why not the PyNet? See, like what happens? Let me show you again. See, I have configured two DHCP routers here. Like this router is also configured like the attacker router if you will verify. So you can see we just verified by show IP DHCP pool. So this pool by the name of attack we have created with this specific network. And this router is also configured. The PyNet router is also configured with the, we can say DHCP server. But here you will see that whichever the router, both of the routers are there, and when the client will send the discover request, the request will reach on both of the routers, because the routers as the servers, they are going to understand the discover request, and whosoever the router is going to accept the receive the discover request first, it will offer the IP first. So this is what the answer to your query is, like the one router, any router who is going to receive the packet first, it is going to offer the IP to that particular discover request. There is no certification for today's webinar, Shubham, but yes, if you are going to attend the free CCNA training from PyNet Labs, then after attending the training, you will get the certification if you have 80% of attendance in that. So you can also coordinate with our team and PyNet channel also over Telegram, and so they will be helping you out over there. So any other queries, guys? If you have, so please just put your queries over the chat box. All right, so why always hacker routers? Why not even the PC discover message was received by PyNet Labs router? See, like the discover request was sent out on both of the routers, right? On the PyNet routers as well, and on the over the hacker router also. But see, there was a misconfliction there that we were getting the gateway from the PyNet's router, and we were getting the IP from that kind of attacker router, right? So this is what basically the difference here. Like we are getting some misconflictions here, and like this is a kind of man in middle attack which is used to destroy the network. So to avoid these kind of scenarios, we are gonna use this kind of DHCP snooping and spoofing. So I hope that answer was fruitful to you, Zishan. So all right, guys, it's we are good to wrap up, or because that was all from my side. So guys, thank you all for joining. Okay, all right, guys. So I hope every query is being resolved, and if you have any other doubts, you can just put your doubts in the Telegram group, which Mr. Dipanshu has dropped the link to join in the chat box. As well as the free training CCNA link has also been dropped in the chat box. So you guys can go through with that link. And if still any queries, you can connect over Telegram group with us. And hope you have a great day, guys. Thank you for joining.